So here, for example, 2, the variable star, Zeta Gemini, has a period of 10 days. The average brightness of the star is 3.8 magnitudes, and the maximum variation from the average is 0.2 magnitude. So assume that the variation in brightness is simple harmonic, so meaning it follows our simple harmonic motion. We want to find an equation that gives the brightness of the star as a function of time when you start observing Zeta Gemini at its average magnitude. So let's start there. So kind of like what we did with the last one, I want to be able to graph this out a little bit. Now, there's a couple key words in here. They give you the period. Okay, so if I divide that by 4, so each interval is 2.5 days. Okay, so time, oops, I don't need the line there. So 10, so 2.5, 5, 7.5, 10. Okay, average is the middle, so that would be going at 3.8. Okay, and then 0.2 is the maximum variation, so that means it gets up to or 0.2 above it and 0.2 below it. So that would be 4 at the top and 3.6 at the bottom. Okay, and since you're starting to observe it at its average magnitude, that means we're starting at 3.8 when we're observing this. So then that should already elicit in your brain that, oh, this gotta be sine, because I'm starting in the middle. So then at 2.5 days, it'd be at its maximum. 5, it'd be back to average. 3.6, it'd be at minimum. And then at 10 days, it'd be at its equilibrium again. Okay, so then now I have my graph. Okay, and so then from there, now I want to kind of put my equation together again. So y equals, since we're starting in the middle, it's sine x. So now I want to piece this together. So, and you can do this in any order. Since it's starting at its average, which is 3.8, I would say that it's its vertical shift. Now, maximum variation would be considered your A value. So that would be what's multiplied the sine there. You're starting at 0 for 3.8. You're not starting at like 2.5 for this, unless you were like looking at cosine, which you very much could. It just said find an equation. So it's still describing the same line. But here I'm going to use sine, so I'm starting at 3.8, which is 0 days. So I would have no phase shift, okay? And then now to find my k value, I just have to take 10 and set it equal to 2 pi over k and solve. So that gets me 10k equals 2 pi divided by 10. So k equals pi over 5. Okay, and so then there is my equation for question A. Letter B wants when the brightness is below a magnitude of 3.7, it makes it hard to see with the naked eye. So how long does Zeta Gemini stay invisible in the sky? So meaning I can't see it. So here for letter B, I want to be able to do what I did in the last example. I'm going to take that value that they gave me, which is 3.7. I'm going to set it equal to my graph, because I'm really just saying, okay, straight across, right? There's those two intersections that I'm looking for, and so then in between there, I can't see it because it's not bright enough. So 3.7 is going to equal 0.2 sine of pi over 5 times x. I'm just going to use x here because minus 0 is not necessary. Okay, and then plus 3.8. Now I'm going to solve. So subtract 3.8 to both sides. That gets me negative 0.1 okay? And then divide both sides by 0.2. The nice thing with this is negative 0.1 divided by 0.2 is actually like the same thing as negative 1/2 or 0.5. So that's a value for sine that we actually know of and have seen before and can easily find the inverse of. So taking the inverse of both, so inverse sine of negative 1/2 leaves me with pi over 5 times x on the right. So now I want two answers that on your unit circle give you the value of negative 1/2 for sine. So looking at that, that would be the y. So you're looking at 7 pi over 6. So there's one equation. And then 11 pi over 6. Now I know usually for inverses we are restricted, but here you're just looking at your graph as a whole, so you don't have to worry about, it's more like an arc sine that we've talked about, and you're not restricted to those certain quadrants, so just kind of keep that in mind as well. Okay, so I want to multiply both sides by 5 over pi. Okay, so then that gets me your pi's to cancel out, so 35/6 over x. Let me scooch this up a bit, and then 55/6. Okay, same thing as we did with the other one. There's this interval of time that this happens, so I want an interval as my answer. I know it doesn't say it, but it's inferring it with how long does it, okay? So it wants to know like when it starts. So 35/6 is in the calculator is about 5.83 repeating seconds, or days, I guess it would be days in this one. And then you can start seeing it after 9.16 repeating days. Okay? And then that would be your answer. Okay? Hopefully this has been helpful, and let me know if you have any questions about how to solve these. But we're just involving what we've talked about with harmonic motion and our inverses. Okay? Take care. Bye.